My name is Anke Neumann, and I'm the current chair of the Clay Minerals Group. Founded in 1947 with an inaugural meeting in Burlington House, the Clay Minerals Group of the Mineralogical Society was one of the first special interest groups that have contributed so much of the life and success of the society. In 2022, the Clay Minerals Group will celebrate its Jubilee anniversary of 75 years of continued research exploring the wonderful world of clays and clay minerals. The group's committee has been organizing and coordinating a Jubilee year of activities and events to excite clay scientists and the wider mineral-interested community alike. Please do join us for these activities, such as the two-day 75-year Jubilee meeting that will take place in the Natural History Museum in London on 25th and 26th of May 2022. We are very much looking forward to celebrating with you the past, present, and future of clay research and the Clay Minerals Group. To keep informed about all that is going on during the Jubilee year, follow us on Twitter or LinkedIn, sign up for our Jubilee year newsletter, and check the schedule of activities and events available on the group's website. Now, I hope you enjoy the following interview, one of 12 interviews highlighting the diversity of minds and hearts behind the fantastic world of clay mineral research and application. I'm very excited to kick off the group's Jubilee year with the first of our 12 interviews that will highlight the diversity of minds and hearts behind the fantastic world of clay mineral research and application. It is my great pleasure to introduce today Professor Adi Radian from the Technion in Israel. Adi earned her bachelor's degree from Shenka College in Israel and her master's degree in environmental studies from the Hebrew University of Jerusalem. She continued with a PhD in soil and water science at the Hebrew University under the supervision of Professor Yael Mishael. She then moved to the University of Minnesota as a Bard postdoctoral fellow before starting her own research group at the Technion in 2016. Adi, thank you very much for agreeing to this interview.
It's truly my pleasure. Thank you for inviting me.
Brilliant. So to start things off, I would like to learn more about your route to becoming a clay scientist. So who inspired you to enter clay research, or how were you introduced to the world of clay and clay minerals?
Yeah, so I finished my chemical engineering degree, and I was looking for a way to move forward. And from my undergraduate studies, I knew that I really wanted to pursue something in environmental studies. And so I found that program at the Hebrew University at the Faculty of Agriculture. And that's where I met my mentor, Professor Yael Mishael. And I started studying under her. And she truly is an inspiration, both as a scientific mentor and also as a person mentor. She really has this fabulous way of balancing, work and science, and in a way that really was infectious. Her curiosity for surface clay science was really something exceptional. And we started working together during my master's, and I stayed for a PhD. And by the time I finished, I think I was for 8 years there. And I really fell in love with it, with the whole process, and also with the magic of clays, which is, a little bit naive, but they truly are something exceptional. And even though they're very, very ubiquitous, they have all these amazing traits that you can play around with. And it really is a very good scientific playground to work with. So yeah, I owe it to her, actually. And I think she made it look possible and enjoyable. So that was kind of my pathway in to the science.
I know that you obviously have continued your research in clay. So from your original work that you've done during your master's and PhD, what is your current interest in clay and clay minerals, or has that changed at all?
Yeah, so when I finished my PhD, I really had that kind of fork in the road. Where do I want to take this? Because I did my master's and my PhD, we kind of played around with the surface chemistry of clays, looking at how to make them very good adsorbents for different pollutants and kind of the environmental route, as I said before. And what got me really excited was, looking at that interface between biology and clay science. And I did my postdoc at Professor Larry Wackett's lab in Minnesota, and he's an environmental microbiologist. And I kind of brought, everything I learned that had to do with the surface science, and we started working with those interactions between bacteria and silicate surfaces. And from there, it kind of evolved. And now I kind of look at I feel like I've expanded, my toolkit, and we look at kind of the interface between biological molecules and clays and bacteria and clays, and we look at both the fate of polluting chemicals in that regard. So, how can we enhance or augment biodegradation with the use of clays, or how do clays affect the fate of biological entities in soil? So if you look at, pathogen transport, clays play a huge role. And so that's kind of one avenue. And the second one is really looking at how we can utilize clays and transform them to be more applicable in remediation practices. So looking at surface reactivity and enhancing that for different solutions for water pollution, for soil pollution. And, it sounds kind of large, but we really love to look at that, the small mechanisms that drive the larger effects. So how can we reach really nice efficiency of pollutant removal by just, changing small things on the surfaces of clays? And a small change can have a huge effect. And so answering those kind of questions, they're really exciting for us. That's kind of,
yeah, that's very fascinating, and obviously also of interest to me. So I really like that approach to go really into the mechanisms to then apply it to something bigger than just the clay minerals. So in terms of your research, you're basically bridging this wide range of fundamental and applied. So what are the, in your opinion, the big clay questions that remain to be answered?
That's a really good question. It's a very large question. And I think since clays are so pivotal in so many different areas, it's hard to kind of pinpoint what are the big questions in clay science, because clay science is so broad. But for me, there's this whole the interplay between clays and life. So there's a lot of unanswered questions, that have to do with the origin of life and the role of clay minerals. And I know that that's a huge issue, but for me, it's more, that going back to that, how do the interactions between biological molecules and clay minerals, how does that change the way that we look at things? And so I think there's a lot of questions that are unresolved that we can really take a deeper look at. I mean, we have now one of the things that we want to start working on, and I have a colleague that's a microbiologist that we're thinking of looking at the effect of clays in the transport of airborne bacteria. And this obviously very timely in terms of the corona, but so we have a lot of big dust storm events here in Israel. And, one of the questions that we want to ask is what is the role of clay minerals in bacterial transport? Do they help with desiccation? Do they select for certain bacteria? Do we get higher infectious bacteria when so all these questions are unresolved, and it's like a small part of a huge question, but I really think that these biological mineral interactions have the key to open a lot of different, answer a lot of different a lot of different questions in those directions. So that's, I think, for me, something of interest, but it's definitely not the only thing. I mean, clay applications, it's such a huge field. I see things coming up in terms of medical applications and food packaging applications. And, so this is such a broad, there's just so many open avenues that you can still, explore in this. So I don't know, a big open science question. There's a lot of them, but I think I give partial answer.
Yeah, no, I mean, I get you. It is a very, very broad question, just to challenge you a bit. And I mean, it also feeds into, the next thing perhaps. So you already said, oh, I'm looking at, clean water, getting pollutions out of the water, looking at how things move in the soil. and now going, to airborne diseases, perhaps. So, in your opinion, which global challenge or challenges can clay science help to address?
So a lot of them, but so thinking about that question, that one of the things that came up was, issues like carbon sequestration and the role of clay minerals in holding in the formation and the sequestration of organic matter in soils. So that, I think, is something that has huge effect. If we talk about climate change and mitigation of climate change, I think we can find several pathways where clay minerals can really make, or the study of clay minerals can really make a huge difference. So I think carbon sequestration is one area where I think it's going to make a huge impact. And again, soil fertility, ensuring food stability, things like that, making sure stopping soil deterioration, issues that have to do with, our sustainability here on the planet, I think definitely is something that all of clay scientists are going to have to are going to touch on in the coming years. And that's not even addressing, the applications of clay minerals in a myriad of technologies that can help with different environmental issues, from, we talked about clean waters and clean soils.
The cat is also interested in clay minerals, so I like
rightfully so.
But coming from maybe the big picture questions more to your personal career, so could you maybe comment on your proudest moment or your great satisfaction or your best clay decision of your research and career to date?
Yeah. So I thought my thoughts about this are a little kind of maybe not so clay based. I think the greatest satisfaction in my work actually comes from teaching and mentoring, which is, it's kind of side benefit, because thinking about where I make the most impact. So I think the science that I do is exciting, but it's at times doesn't feel very, I think it's incremental and it will help and it advances and I hope to do big and important things. But each year I mentor students and each year I teach classes that, some of my classes have 150 students, others have 15 students, but I feel like I get an audience of people that listen to me ranting about the importance of clay minerals and the importance of soil health and maintaining a clean environment and what we can do to help with all these environmental issues. And I feel like that's a place where I'm very where personal satisfaction is relatively high. In terms of my personal accomplishments, I think I felt most proud when my first paper came out as a PI coming here to the Technion, because it was, an idea that came to life with me and a student that I mentored, and it also took a long time, and it wasn't an easy path, and it was the first time that I kind of did that whole bacteria with clay for remediation type of melange. And so I think when that was published, I felt kind of like, okay, I think I can do this. And, I enjoy doing this, and this is what I want to continue doing. So it was kind of a yay moment.
Coming from your yay moment, maybe, to the dark side of it. So do you also have, work that failed to produce the results that you had hoped for, and that still made you or gave you insights?
Yeah, so there's been many projects that did not turn out the way I originally thought they would, and I always I tell my students and myself that if we knew the answers ahead of time, it wouldn't be interesting. And so, but we do try to bring everything into the light. So even if things don't work, we try to find a way to make them interesting enough to tell the scientific public about them, because I wouldn't want somebody working for 2 years in their lab doing exactly the same experiments that I did and finding out again that it didn't work. So, and there's no paper for, unsuccessful attempts, and so, or no journal for unsuccessful attempts. So one of the things that I pride myself on is making, lemonades from different lemons. So I had a few failed attempts that, we kind of twisted around to show that they actually mean something in another realm. So we had this, for example, we had this project that we were working on that we tried to harvest ammonia from cyanobacteria with the help of clays for organic fertilization with ammonia. So not to use Haber-Bosch, but to use organically harvested ammonia. And we couldn't find a good way to actually harvest the ammonia, but we could find really good ways to kill cyanobacteria. And so, working on that for 2 years, we decided that we should tell the world, if you do this, you'll kill them. If you don't do this, you won't kill them. And I thought this will be helpful. Even though we did not accomplish our original goal, it's still, I think, a good way of kind of showing what, we didn't say we tried to do this, but we failed, but we did show how to successfully kill cyanobacteria with clays. And so if somebody had any idea, any thoughts about, trying to harvest ammonia with the specific clays that we were working with, maybe they would think, again, after reading our paper, about how to do that and maybe come up with a better, more successful idea than we did. But yes, definitely it happens quite a lot. And I think it's not part of the fun, but it makes the highs a little bit better if you have something to compare it to. So yeah, definitely a lot of failed attempts.
Yeah, it's a very interesting and creative way of using failed experiments for the good, right? It's something that we all have to deal with. So in research, at least. So
definitely,
it's great
every day.
So we talked about clays and clay minerals and how to make them work. But do you have a favorite clay? Which one would it be, and why would you pick it as your favorite?
Yeah, so I do have a favorite clay, and it's the ubiquitous montmorillonite. Mm-hmm. Just because it can withstand all the crazy ideas that I've had over the years, and let's attach this, no problem. It can deal with anything, and from all my attempts, it's always the one that has because it's high surface area and it's very unique properties. It seems to be the one that I can manipulate or change, transform the easiest. But yeah, it's not that I don't like the other ones, so don't tell.
Reliable companion. Yeah, I can see that. That's important. Right. So when you look back at your beginnings of your clay research career, do you have any advice for students or early career researchers when they're starting a career in clay science, or an advice that you would give to your 20-year-old self before entering the world of clay science?
Well, I think it's pretty much the same advice I would give any starting scientist. Perseverance, don't give up. Success is often very few and in between, but that's the way it is for everyone. And also, enjoy the little things. Clays are not bacteria. Clays are not mice that you have to feed. So there's kind of advantages to working with, inorganic materials, conformity, consistency. So kind of enjoy that. And also, I think one of the other things I would say is don't assume to know what you're going to get. So often, you get like a result that's unexpected and you're like, oh, I'll just do it again. And then you get that result again. You're like, okay, something's not working. I'll work on something else. And I say, wait. Often, the most interesting outputs are things that you don't expect. And maybe it's not a mistake. Maybe it's something interesting to look into further. So I think many of the interesting findings all across science weren't like eureka. They were more, that's kind of, an interesting point. And I'm kind of regurgitating also things that I've heard before, but I think it really is true that, take a moment to think why things have failed. Often that would be a good pathway to kind of pursue.
Yeah. I like the idea of serendipity in research very much. And yeah, it just happened. So we just need to keep our eyes and ears and
Exactly.
everything open, all of our senses to the things that come our way.
Exactly.
Well, we heard a lot about your research and your path into the research, but I guess you also have a life outside of working. So when you're not working on clays, what do you like to do?
Well, I have 3 small boys and slightly older husband. So for the 4 of them together are often a handful. And so I spend a lot of time with them, and a lot of my energy goes there, picking them off the walls. But I also have a bunch of hobbies. I don't often talk about them, but I do dance. So at least once a week, I take time off and I go to dance class. Make sure I have some time to kind of, let off steam and, take care of myself. So, yeah.
What do you dance, Adi?
Classical ballet. Don't tell anybody.
Wow, that's impressive.
I don't do it in an impressive way, but I've done it for many, many years. So even throughout my postdoc, my PhD, I always take that, time once or twice a week for myself.
Yeah.
I don't think I'm going to become a ballerina.
That might be a bit too late in your career. I agree.
Maybe, but still, it's nice to have that kind of small compartment that's, dedicated to myself and to time with good music and kind of letting go.
Oh, that's really nice. I'm going to look out for, your guest appearance in the ballet soon.
I would not hold my breath.
Right.
But I'll let you know if anything.
Yes, definitely. So just to come to an end to this interview, if you had the chance, who of your clay heroes or heroines would you want to interview?
That's a really tough question. There's a lot of people I've been following over the years. I remember, the first time I went to a scientific conference and I saw the names of the people that were on the papers that I was reading. It's like, wow, rock stars. But I think, 2 great scientists kind of come to mind. People I've been following and still am following. So one of them is Professor Ravi Naidu from the University of Newcastle in Australia. And he is doing so he does a lot of work with clays and in environmental aspect, but also that whole biological, bacteria clay interactions and that whole interplay, which I find really fascinating. So a lot of his work has inspired the things that we do in the lab, and we're following him, and I wouldn't mind picking his brain. And the other one is more of a material chemist, material scientist, Professor Yuri Lvov from Louisiana Tech. And he is more does more, material design, clay-based materials for different applications, drug delivery, pesticide delivery, and he does encapsulations of bacteria in different silicate capsules. And again, things that are really inspiring, and I always find in their papers things that I kind of like, oh, that would be a great idea. I'll take this and I'll put it together, and that. So yeah, those are the 2. But there's really a lot of others. People are doing really great work, and it's a lot of fun to kind of look at the people's different ideas, and so I don't know, it's a tough question, but I think that would be
So maybe we're going to come and approach you if you want to do an interview like this one with one of your heroes or heroines, maybe next year, maybe in 10 years when we have another Jubilee year to celebrate. Who knows? But thank you very much, Adi, for, answering all of my questions, the hard ones, the funny ones, and maybe the ones that are, a bit shrewd and not so easy to answer. It's been a pleasure talking to you. And I hope that this interview will inspire a lot of people to, take a better look at clay minerals and join our ranks or go off and do something with clay minerals that we might not even think about doing with them.
Exactly.
Thank you very much, Adi.
Thank you for having me.